Listeners, thank you for joining us today as we explore UV LED curing with Phoseon. Today's topic is on successfully selecting a UV LED supplier and implementing UV LED curing. Keith Despain is our expert presenter, and during this session, he will compare and contrast the differences in performance of UV LED-based systems. Keat is the Vice President of Marketing at Phoseon and has more than 25 years of experience in semiconductor and embedded systems marketing. By the end of this session, you will learn how to choose a UV LED supplier and define the right questions you should be asking when selecting your curing systems. Today's presentation should last about 45 minutes with time for Q&A at the end. So on your computer screen, you should see a control panel. And if that's not open, you can just click that orange arrow to make it larger, and there you'll see a drop-down box to ask questions. Now, please do so at any time throughout the presentation. Also on your control panel, you should see a number of white papers and case studies from Phoseon that are available for download. And finally, once this webinar is concluded, you'll be able to listen again at labelsandlabeling.com. So Keith, thank you so much for being here today. If you want to take it away.
Hi, Chelsea. Thank you. Thank you. And thank you to those who have chosen to either wake up very early this morning on the West Coast or in Europe. Thank you for making time in your afternoon. And those maybe in Asia Pacific, thank you for staying up very, very late. Look forward to sharing with you today our topic of some of the criteria that we see some of our converters or OEMs when they make a choice on what kind of UV LED curing solution that they want to offer into the marketplace. And joining me is also Sarah Jennings. Sarah Jennings works at Phoseon as our technical lead for our flexographic market and for the products that we are driving into that space. So with that, I'll get started, and feel free to send over questions. We do have a lot of content, and I will try and save some time, like 10 minutes at the very end, to definitely get to those questions. So once again, thank you for joining, and we'll jump into it. So just a little bit about Phoseon technology. Won't spend too much time here. We've been in this business now for almost 16 years. We were one of the very first to begin the innovation to this market, to start looking at how do we take solid state lighting that we find back in the early 2000 time period and move it into the industrial applications. And the largest market that we have been serving for many years now has been in the printing side of things. And just a few facts down below of our market presence and how many lamps we're selling, and our patents followed up by a proven lifetime. And some of these are very critical as you look at making your choice as to what kind of curing solution do you want and who you provide that from. I thought I'd stop and take a quick poll question just to make sure that I can address some of the questions on the audience. And so our first one is all around, how familiar are you? And based on that familiarity, we will determine, how much time we'll spend up front. But let's take a little moment here.
Yeah,
we'll give Chelsea.
Yeah, we'll give you about maybe 20 more seconds to answer this as the poll questions are kind of rolling in, or the responses are rolling in here.
So as we tabulate that, we'll move on a little bit. Chelsea, have we got our...
Yeah. So I'd say about 45% said they're familiar, that they have done some research, and then the next highest was 36 was unfamiliar, that they're here to learn. So
great, thank you. So with that, then I'll spend a little bit more time then on how that impacts converters when they move to UV LED. And you'll hear us talk a lot about more. It's been a campaign of ours for quite some time now. And what we are finding as we do implementations of UV LED, and especially into the flexographic market, that the real benefit of LED comes from the side of more productive. So the ability to really increase the amount of output that your presses are able to generate on a daily basis, whether that's minimal maintenance that is needed so they can run longer, or increased yield. We're certainly seeing upwards of almost 30% on increased yields. And then at the same time, the press is just able to do more and run faster. Reliability is up. Short runs are capable of being performed. quick job changes as you're not really worrying about what's happening with the lamp as the LED is fully programmable. And finally, a more repeatable process that is consistent and able to put out good product run after run. What we're also seeing is that the economic benefit, as well as the high quality of the print, is enabled by UV LED. We reduce the energy. We allow you to do more with it. There's safety. We reduce the overall infrastructure that's needed as you take out some of the infrastructure that was needed for mercury arc lamps in the past. So take out the exhaust, the air exchange. You don't need to worry about some of the roof penetration. You can eliminate many of the consumables that go along with that, which are all about, how do we make sure this is more efficient for you? And finally, we're seeing as we work with our consumable partners and ink and formulators, the high quality print that we're able to deliver. More opaque whites, no compromise on the color gamut, some metallics. We're starting to see lots of innovative metallics, as well as the thickness of those metallics that really, when consumers are looking at the labels, really pop and catch that eye, which then increases the amount of time and the purchasing that they make when they're looking at these products. So I just want to touch on that really quickly, just some of those 5 benefits that we see at the converter as we really want to jump into the technology. But before I get there, let's just talk about what we're going to discuss. And so here's just an example. And a lot of us have bought cars in the past. And so I thought I'd share a little bit, a curing solution is a complex purchase. There are many things to be thinking about when you buy that curing solution, but we try and make it as easy for the user as possible. So many users know how to operate a car. You need to push the gas and the brake and how to put it into drive. That's the simplicity that comes along with that. But there's lots of criteria, whether it's safety, fuel efficiency, suitability for everyday use, lots of different criteria. So let's keep that in mind as we run through some of these other aspects. So how we break it down is really 3 major considerations. Who's your press operator? Who are you buying your press from? What is needed in your environment? Do you need a new press, or are you doing some retrofits? Who are the consumables that you partner with, the ink providers, the substrates, the coatings? And finally, what is that UV LED solution? And that's today's focus. We're going to spend most of our time on that, but I thought I'd at least touch a little bit on those first 2. Well, before I jump into that, maybe we'll take a quick poll on those who are listening in. If they've thought about, would I retrofit or would I buy a new press, or still undecided? So Chelsea, maybe you could open that up for a minute.
Yeah, sure. So again, we'll give you a little bit of maybe 20 seconds or so to tell us where you are.
So this we find is a very important question because it determines, one, how quickly do you move into offering UV LED curing as part of your portfolio, or do you want to install a new press and go through the process of getting the full benefit of the newest and latest technology? So that's one of the key decisions that we find.
Okay, and we've got some really interesting results here, Keith. There are 57% that voted said they're undecided, and then 29% said they were doing a retrofit, and 14% said they were doing a new press. So kind of interesting results there.
Oh, great, thank you. I think it's what we see common across a lot of what our customer base is telling us is they're here to learn. They would like to know what is the opportunity on which they do. So one of the reasons for this webinar is to certainly provide some of that from our insight. So thank you for sharing that. So as we look at just press versus retrofit, some of the questions that we get asked or asked back to our customers, well, is the current press that you're using, is it fully amortized? And where's the bottlenecks, cost of ownership? These are things that need to be asked, and certainly the accountant side or the financial side needs to be looked at and drives a lot of how we respond to this. But our first, what our key learning is that if you have had a press that is anywhere between 5 to 7 years old, a lot of times people start looking at new presses and should we just do a full replacement? But retrofits are, if it is over 7 years or under 7 years, but less than 3 or years or so, then that is when they start looking at retrofits. They've already had their press, they know how it runs, and now they want to move to a new curing capability that brings in the benefits of UV LED. And so anywhere between 3 to 7 years are doing retrofits. If it's older than 7, a lot of times they will move to purchasing a new press. Now we have done some retrofits ourselves for presses that have been in operation well over 15 years, and they do have some unique capabilities that they just need a new curing capability, and that's what we bring to the table. The next one is all around formulations, and we wanted to share a little bit here around what we're seeing in the marketplace. UV LED has been in this market for quite some time. There were certainly some challenges at the beginning with any new technology, but we feel today, if you can see the max press speeds that we have listed down the middle, that the market is maturing very quickly, and we are not seeing anything that is in the way these days to keep us or our customers from moving to UV LED. Everything from the inks all the way to the primers to the cold foil and all the way down to various specialties. Fastest speeds are certainly 300 meters per minute, 1,000 feet per minute. And that's really fast. And we're finding that the curing is no longer becoming no longer the bottleneck. And a lot of times as we open that up, it allows the press run faster and make sure that we're putting out more output than previously experienced. Some of our partners that we work with, this is just a strong list for us, but also if you go to Phoseon.com and our resources, you'll be able to see who all our partners are. But we work very closely with Seagworks, Flint, Paragon, Sun Chemical, Nasdar, and Zeller Gamellen, and we enjoy what we do in our partnership because it all has to come together in a final solution. It can't just be, worrying about the curing solution one at a time, but thinking about what is the press, what is the ink, what is the substrate, what are some of those variables that we have to understand to make sure you're getting a good product at the end. So let's dive into it around a UV LED technology. So we've talked about the press, we've talked about the consumables that are needed, and now we're going to jump in and spend the next 30-40 minutes talking about just LED technology and the products that are there. And our criteria that we have here is about 7 different areas that we look at. Certainly there's many more, and as you make your decision, and I just put down a spider graph down below that just kind of shows you, areas to think about, and every customer has different levels of importance. We have some that are in South Africa that are more worried about energy and how are they able to run off of solar power. What are some of the other things that we need for medical or life sciences type applications where we have to ensure there's a consistent uniformity and stability. So we're going to run through each one of these, and feel free to ask questions, and again we'll gather them as we go through this presentation. So the first question we usually have is, well, what's the difference between mercury lamps and LED? And a mercury lamp across the spectrum, the wavelength spectrum of light, is covering quite a broad spectrum, and it allows the coverage with a lot of heat and intensity that comes along. Whereas with LED, it's a narrow spectrum, and a lot of times you'll hear things thrown out there like, well, 385 to 405 nanometer. Well, what that means is that is the peak, and that is the core focus of that LED in terms of the light wavelength that's coming out. But it does have a bell curve, as we show in the middle here, that it does go from, typically if I'm on a 395 nanometer, we are reaching all the way from 365 up to 405, but the main focus of energy is coming out at the 395. And that's important because you do have to, with your formulations, make sure that they are tuned to that certain range to make sure that there is a nice cure that is happening. What is interesting is that we're seeing that most of our customers are in the range of 395 nanometer. That's what we ship most of. We do see 385 and 405, with 365 also starting to improve, but I would say well over 90% is at 395 nanometer. One of the interesting things that we are working on is also 275 nanometer down into the UVC range on the far left side. This is a new development as the technology is maturing. Today we see it that it's not nearly as mature as the UVA wavelengths, but it is coming on strong, and it does offer some nice properties when we talk about the surface cure and how well is that surface cure occurring. So that's something for us to keep watching, and as we do our experimentation with our partners to make sure that the chemistry is also in place, we find this is something that we need to pay attention to. So determining what that wavelength is and what your ink provider is recommending is very important to understand at the first. The next question that we usually have is, well, should I go with a water-cooled or an air-cooled solution? And each one has their benefits and a few drawbacks, but the benefits we've listed here are noted around water-cooled. If you want to deliver the highest irradiance and the highest dose available, is the way to go. But we're also finding that with air-cooled, we are now at the point where we deliver a sufficient amount of irradiance and dose. So that's why we call it high, and then the highest that go along with that. The benefits of air-cooled are really the simplicity that comes along with your curing solution. You do not need a chiller. You can replace a lot of that infrastructure that's needed to make sure that with a water-cooled capability, that those lamps are remaining cool. But with air-cooled, we're just using the ambient air around the press. Some of the dimensions are important as well, certainly with water cooled because of the heat sink that goes inside the lamp, and we'll talk about that in a minute. It can be very efficient and very small. Don't need a fan. There's not a moving part on there, so it allows us to get to a smaller dimension. But we have found also that with the air-cooled capability, we can fit into 99% of the presses on the marketplace. Solution energy and consumption is about the same. You get a little bit more with the air cooled, again, because you remove the chiller and some of the other components that are needed for a water cooled capability. And then finally, maintenance is much simpler with air cooled in this marketplace. You just have to make sure that you're cleaning the window on both sides, but also then changing the air filter versus monitoring the chiller temperature and water quality we find on water cooled. The nice thing is that both solutions are in the marketplace. Many providers are out there for these UV LED solutions, whether it's water cooled or air cooled. Phoseon is seeing that many of our customers are moving in the direction of air cooled, but we do have water cooled offerings as well and continue to lead that marketplace. The next question is understanding then what is the total UV output? And there's many ways to look at this. This is probably the most complex area that we work with customers, is understanding and defining what that is as we look at the marketplace. Most of the market in the last few years has been driven by the left-hand side of the graph that talks about irradiance or watts per centimeter squared. Many of the providers in the curing solution space measure their lamp performance off of this and say, you know, it's going to run at 16, it's going to run at 20, it's going to run at 30 watts per centimeter squared. That's only a small portion of the formula that is needed to have a good curing solution. It is important, just like gas mileage is important in making your car choice, but if you need to also look at the performance, the overall capability of the vehicle, if you're towing a boat or if you're towing something, you make a different decision. And so that same formula needs to come in as you make a decision around your curing platform. And irradiance is one, albeit a very important element of what we need to make a decision. There's also what we call energy density and dose. And this is coming by the total UV output of the lamp. And so what we have found is that as we increase the amount of UV output by increasing the number of LEDs found in the lamp and by increasing the emitting window, which we'll talk about in a minute, we're able to increase that total energy density and dose, as it's been known. And we usually measure that in joules per centimeter squared or millijoules per centimeter squared. And we need all these to be balanced and well delivered into the substrate, as well as to the inks and to the chemistry that we find going across the press. One of the interesting things is that as we work with our customers, we're able to see that sometimes you can actually reduce the irradiance, but open up the total amount of exposure to deliver a better curing capability, and that allows you to run a little bit faster, albeit while you're still delivering a higher UV output. So let's dive into that a little bit more. And we have four lamps that we have showcased here. And I'll start by one is water cooled on the left side and air cooled on the right. And we have different offerings from a 20 millimeter emitting window. That's just the amount of light that is able to come through the window and out onto the uh, the substrate and across the web that is coming through a flexographic press. And the other one is a 40 millimeter. One's an FL 400, one's a 440, and again, we add that into our product number to make sure that we're clear on those emitting windows. What that does is that drives some of our energy density. And so the formulation that we have here is based off of our experience on working with various press manufacturers as well as converters. But we just decided we would take a 200 meter per minute calculation at a working distance of 5 millimeters. And all of these are important to determine how much energy density is actually reaching the chemistry. And so as you can see, the largest amount of energy density or dose is 180 millijoules per centimeter squared, working off of our FL440. Now we have products across the spectrum, and you can drive that higher, and you can also go down to, and some of our 20 millimeter emitting windows, all the way down to 93 millijoules per centimeter squared. But the irradiance is another thing that makes this interesting, is we need to look at that. And so as you can see in the middle, between an air-cooled solution, the FJ240 with a 40 millimeter window is delivering the same amount of energy density as a 20 millimeter water-cooled solution. And the difference is the irradiance found below. One's at 12 watts and one's at 24 watts. And so this all goes into what determines the curing of the formulation and what do you need? Do you need higher dose or do you need higher irradiance? We have found that the thicker the chemistry is, or the ink or the coating or the adhesive that you're putting on, you might need a higher peak irradiance. But if you're running a very nice ink, if you're printing very quickly, if you're running on silk screen, if you're running on a shrink sleeve, you don't need as high of a peak irradiance because you want to keep your energy at a nice level across the spectrum. And so you can reduce that peak irradiance and deliver 140 millijoules still with the FJ240. This is our key focus in the last few years, is to understand this, work closely with the chemistry, and this is what drives a lot of our future investment going forward. So what we found is that, again, working with the formulators and working with the press manufacturers is important to understand what are the key outputs that the converters are looking for to develop the right formula. Sarah, is there anything that you would like to add at this point on the difference between dose and peak irradiance?
Maybe just to relate it to press speeds. We have seen that with a 20 millimeter window running at 20 watts per square centimeter irradiance, that's where we can hit that 1,000 feet per minute or 300 meters per minute speed. And so even though we list the doses here that are much higher, that's not always necessarily needed for your application. So depending on your press speed, you might need lower energy. You might need a smaller emitting window. But it's working with your press, knowing what your maximum press speed is, and then working with that ink supplier to make sure that we're providing the right product for your application.
Thank you, Sarah. So I think that critical for us is being able to have that flexibility across the offerings that that we have on the curing solution to then tune that to the specific needs of each press and each operator. So I'm going to stop there, and I know that many of you are trying to understand and make a decision here, but we thought we'd ask the question. If you've looked into this, have you determined, do you need higher irradiance for your application, or do you need greater dose, need both, or unknown at this time? So we take a moment and maybe stop and see what the market is asking for.
All right, yeah, we'll just give you guys a few more seconds to vote. And the questions are rolling in, so please, feel free to keep sending them, and we'll get to those at the end with a Q&A session. All right, I'm going to go ahead and close the poll so we can move on. 79, the greater majority said they are unknown and they need to run some more tests.
Thank you. Thank you for sharing that. I think that is very common at this point in time, in that we have really seen just in the last 18 months a greater focus on understanding what is the dosage requirements, the energy density requirements that each presses have. The other interesting thing that we're finding is that as we look across this, there's nothing that is not available in the technology today to solve each and every issue that we run into. And so I think that gives to the maturity of UV LED at this point in time, to where we can quickly determine what is the right combination, working with the right formulators as well as the right lamp to deliver the best curing solution. The next area that we are seeing is about stability and consistency. And when we talk about stability, this is really understanding the light and the energy output across the lifetime of that LED system. As we show here, we're showing 20,000 hours, and in a few minutes we'll share some information about what the expectation should be. But most people in this industry are saying 20,000 plus hours is what your lamp should be lasting under all the right conditions. But looking at specifically just the output and the power of that LED system over time, it does degrade. But as you're shown here, it should stay well above 80–90% over its time, whereas mercury arc lamps last probably 400 to 800 hours worth of time before they burn out, and then they're replacing them. And that's one of the key benefits of an LED system, is that it does not need that replacement over such a short time. And so the cost of mercury, as it adds up through the amount of replacements that happen over that 20,000 hours, really surpasses what an upfront LED system is today. But it's important to understand and ask your providers for their curing solution if they have modeled what that stability is over time. Here at Phoseon, we have certainly done that. Again, with our history, we've been running lamps in our own labs for well over 70,000 hours before we're seeing some fallout. So that's one area to ask and say to your supplier, what is the stability? What is the lifetime expectation of that LED system, and where does it come in? You'll hear some terms like L80 or L90, meaning that the output of the LED is well above 80% at an L80 or above 90 at an L90 over the life of that product. One of the other things that we find, and one, why is this so important, is, well, right in the middle of your press operation, if you have let's say you're doing well over 2,000 meter of substrate that you're running and printing on, and in the middle of that you discover that your curing solution is no longer performing, then there's a lot of waste. And so understanding that stability and being very familiar with that as you do testing will help avoid that waste. The other side is consistency, and that determines a good cure throughout the entire run that you're having. Is it consistent? And what we find with LED solutions when you first turn them on, very different from an arc lamp. You do not need 30 to 45 minutes to warm it up in the morning or before your operation starts for that day or for that work team. And so it does go up a little bit above 100%, but settles down at 100% very quickly. Typically between, we've seen some competitors at close to a minute, where Phoseon is less than 10 to 15 seconds in that space to settle in. But then overall, on time, with our target cure capability, as the amount of time goes over, we're able to keep that consistent output by the technology in the lamp to continue to increase and drive the energy and the currency into those lamps to maintain that nice 100% LED output. The next one that we find is also across uniformity. There are hundreds of LED diodes found in these lamps, and making sure that each one of those diodes is tuned and balanced across the length of the offering is incredibly important. And there's things where we scale these lamps side by side to make sure that we're moving forward. What we wanted to show is the working distance. The further you move out, the more uniformity that you have. But most of our presses are running between around 5 millimeters. And so there is this little wave that happens as you go across these LEDs, and the companies that can tighten that up and stay, well above 90% are the ones that can provide a really nice uniform output curing solution, though, so that when you look at your print jobs that you have moving forward, that across the spectrum, across the substrate, there are not areas that are streaking, but fully cured across that capability. So it's important to understand this uniformity is a key requirement to ask, and any of the LED suppliers in the market, if you ask them to show their uniformity by lamp, they should be able to provide that for you and give you the confidence that you'll see their UV output over time. Certainly Phoseon does that. So what's the magic that goes into building these lamps? The first and foremost is the ability to deal with the environment. The operators, in terms of what they're doing with their presses, oftentimes require a very rugged package. We have customers who we work with to understand what they're using and how they're doing, but there's ink spills, there's chemicals that are falling on here, there's dust, there's lots of different environments, as we've all been into these operations and see how they're working. And number one, if it's not a sealed environment, certainly with a water-cooled solution, it needs to and must be sealed. But also with the air cooled, you need the filtration that has to happen with the air, and to keep out as much of the moisture and as much of the chemicals or the ink that may be spilled onto these lamps. So rugged packaging is important. The electronic controls that are then, we just talked about the uniformity, we talked about the stability. Those are all electronic controls that, as you move to a digital environment that we find with solid state lighting, we're able to bring into the market, and that efficiency of understanding what that digital environment is what drives some of the performance of the lamp. Certainly the heat sink and how you cool it. This one is critical. Understanding how to take the energy that is not pushed through the lamp out as light turns into heat, and how do you extract that heat from the lamp in an efficient manner to give you that 40,000 60,000 plus hours is incredibly important. And those lamps that have been tested over time certainly show the benefit of having a really nice heat extraction, a custom heat sink, to make sure that that is being done in an efficient manner. Finally, the arrays and how you lay out that arrays drives, again, that uniformity and the ability to deliver the light and the energy right at the substrate as needed is incredibly important, with a nice consistent micro optics to make sure that, one, we're keeping the operator safe, and two, delivering the amount of energy focused where needed or widened where needed for a greater amount of dose. Some of the actual lifetime testing that we see from our Phoseon labs on which we do. This is showing a lamp that went to 60,000 hours. If you think about that, 60,000 hours was, we started that in 2011. We see many curing companies out there that have not even been in existence for more than 3 years. And so how are they able to show that these lamps are able to last 60,000 hours as they do accelerated life testing? Well, we do that as well, and that's important. But at the same time, we have lamps running in our environment consistently for the last 6, 7, 8 years to make sure that we can deliver on the commitments that we're making to our customers. Currently, we have a 3-year lamp warranty when we do an installation, and this is, I think, industry leading, and it shows our commitment to be able to deliver that 25,000 plus hours into the marketplace. But we do have customers that have shown that they've run 7, 8, 9 years because they're maybe not running 24/7, but they're maybe using a 1 8-hour shift a day. And if you think about that, you can go many years before you reach that lifetime expectation of these lamps. So maintaining that intensity well above that 90% or even 80% as we need in the marketplace is incredibly important. And we see that quite doable beyond the 25,000 and 40,000 hours that we're seeing in the marketplace today. We also have, in a real world experiment, done some checkups. We've have a customer who has just passed the 3-year mark, running 16 hours a day. We look at his lamps and make sure that they're performing well, and they're well above the 90% side after the 20,000 hours of running. And that is pushing it very hard if you look at the LED actually running 16 hours plus a day. Moving into some of the products that we have. So we've talked about the technology and those key elements that are needed. Now we're going to turn a little bit just to some of the products that we have in the marketplace today. We have a water-cooled and an air-cooled solution. The FP601 and our FireJet FJ605 is an air-cooled solution. We have the lengths, everything from 300 millimeters to 675 to be able to cover the distance that is required across the narrow web all the way out to starting to see what I would call more of a mid web and also onto a wide web capability as we scale some of these side by side. But for the FireJet and the FP601, it's really focused on the narrow web area. The next thing that is important is bringing the whole solution together. And so we have what we call the Flex Tower. The Flex Tower is a capability of delivering a lot of energy, a lot of power to the lamps to deliver the energy that they need to the substrate, and how you control that. So some simple touchscreens that allow you to manage each station. It integrates nicely with the various presses and can be set to run by the press speed, then determines how the lamp intensity is running and how often you're able to hit the substrate with the energy that's required. Running through this very quickly as I want to make sure I get to some of the questions near the end. Just a little bit of a deeper dive on the FJ605. We also have technology built into these lamps that allow you to have more of, as we've talked about, the consistency that's needed. So TargetSure is a technology with a patent around how do we deliver real-time UV irradiance monitoring. So the capability to really tell the press operator, is their lamp running sufficiently to ensure that issues like low migration are being covered, because they can feel good that the curing is happening at the necessary energy that's required to deliver a nice full cure. Whisper Cure technology in the air-cooled environment allows you to reduce the fan noise and monitor that noise level to make sure that the operators who are constantly on shift are not bothered by the amount of noise coming from the fans, as they do run quite efficiently, but at the same time do put out noise. And so we want to make sure that we can moderate that. And finally, Target Cure, as we talked about before, is about the ability to offer stability and uniformity across the platform to make sure that we have a stable delivery of energy over the life. Some of the other aspects that are needed are understanding, well, how do we exhaust? What are we doing with this air and moving it across? We also have the ducting capability for water cooled as well to be able to pull that out, but mostly on the air lamps and how we manage that. Maintenance, putting in these retractable capabilities, be able to get to the window. We do recommend that you're checking the window often to make sure that it's clear. The light can hit that ink, and if the ink is cured right on the window, that light can bounce back into the lamp or create more heat because it's not being released outside of the lamp. So it's important to continue that maintenance and to scrape those windows as necessary to have sufficient life for that lamp. We do have protective windows as well, often found in environments that are incredibly dirty. This environment, or where we place these lamps, you can quickly pull that protective window off and put a new one on while you're going clean the older one. Again, it's all about how do we make sure the uptime of that press is is of paramount to be able to deliver as much as possible. So any chill plates to make sure the substrate is staying cooled as necessary. The energy that's coming out of these lamps, the UV energy, will hit those plates, and it is absorbed. And so we are seeing that we need to offer chill plates in various circumstances. Sometimes you don't. We see, depending on the environment, is what our customers are asking us for. And finally, the integration services and capabilities of a company to actually do installs and do it in an efficient manner is incredibly important. The last I'll touch on very quickly before we jump into a little bit of a case study is, other considerations as you think about your curing solution. Well, what is that warranty? What is the capability of the company that you're working with? Is it global from a support perspective? Phoseon's been on the market for many years, and so we have a global presence for our service engineers and can work closely with our customers around the world and installations from Asia all the way through Europe. The availability, we're starting to see that as this market continues to grow at a very fast pace, our manufacturing facilities need to be able to keep up with the demand. And we've recently expanded ourselves, but understanding that supply chain all the way from the LED diodes all the way through to cabling that is required is incredibly important. We manage that 100% ourselves and do not do any outsourcing. Finally, our IP protection. We have seen in this case, this is a technology market and patents are important. We would hate to see a press manufacturer a press operator that needs to shut down because he'd chosen the wrong technology that was not protected by patents. We've seen some cases where some of the diode suppliers in this marketplace have actually gone after end users. So it's important to understand what is the IP protection and the capability of the provider of these curing solutions to protect their customers downstream. And finally, as we know, it's important, just like making a car decision, you usually ask your friends, you ask other people, what's your experience with the various brands? What have you done? And so getting those testimonials is incredibly important. Phoseon has shipped well over 110,000 into the market for the printing industry and can offer many testimonials. And if you'd like to talk to any of these customers that are currently using it, even in your application, we can set that up as we are across the board of the applications that we do and can deliver quite a good experience, and we'll introduce you to those customers who have already made that decision to move over to UV LED. Finally, that brings us near to our end of our last question. As you think about your decision criteria and the things that we just ran through, what would be, in your mind, one of the key decision makers for you to choose a UV LED solution? So let's stop and take the poll there.
All right, and we have loads of questions to go through too after this. So we've got a lot to talk about still. So
I'm trying to leave 15 minutes for those questions. I'm talking as fast as I can, probably too fast, not driving into too much detail, but definitely look forward to those questions as we'll get to them in the next 2 to 3 minutes.
Yeah, no, you're doing a great job. This is really informative, I think, for a lot of our viewers here. All right, so I'm going to close the poll here and just say 39% said performance enhancement for their press was the main decision. 28% said reduced operating costs were the top two.
Awesome, thank you. That's you're making me smile as the head of marketing here at Phoseon. When we see a performance enhancement on presses because of a change in the curing solution, that is one of our best benefits. That when we think about the total cost of ownership, that moves the needle more than anything else. We can certainly offer energy savings and operating cost reductions, but if people want to look at their total cost of ownership and get that payback as soon as possible, the ability to increase the output moves that metric faster than anything else. And we've seen those who have increased 30, 40% their output based on their curing solution change. The payback is under 6 months. When it reduces, it stretches out to 1.5 to 2 years. We rarely see it go beyond 2 years because of the operating cost savings, but also the output increase that happens. So great feedback. Thank you. So last, I wanted to share with you, and I would love to show you a video, but I think it would take too much time. So I want to talk a little bit just about the case study that we had. We had a customer came to us who had chosen a solution, a curing solution, bundled with an ink supplier. And the ink supplier is very well known in the market, understands this industry from an ink perspective, but had a little challenge with his curing solution as much of it was outsourced. And when the customer implemented it, certainly had great expectations. And the first month ran fantastic, was very excited. The second month was okay. The third month started to see some issues. But by month 6, those lamps were now down to 80% of the promised power. Now, we just talked about the lamps should be lasting for years, not for months. And just imagine the impact on your operating line, on your press, if your curing solution dropped from 100% to less than 80%, delivering about 20% power in 6 months. Well, what happened was going from 100 meters per minute down to less than 10 meters per minute. Added increased shifts and workers to cover for our customers, and then lost some customers. So he came to us asking for, our offering. What could we do? We did a complete retrofit. Obviously, we had to take some measurements, come in and make sure it was there. But once all the equipment was ready to go, that install took less than two days. It's now running well over 150 meters per minute. So we obviously saw about a 50% increase over what the other curing solution was providing. And we have assurances in place that will allow that to run for 20,000 plus hours of run time. This is a great video. Please go look at it on our website or on our YouTube channel that we have. But I think it gives a pretty good experience for how to be very cautious. We love our ink providers and the formulators, but again, I think it comes down to really understanding the technology, and those who have been in the LED space for quite some time will be able to deliver to that 20, 40, 60,000 hours of runtime, because that's what we do all day long, and make sure that we're delivering that to our customers. So in summary, just running through it very quickly, just how we ask and the questions that we look at, air cooled or water cooled, the irradiance is important, but more than anything, it's how do we specify the wavelength, the energy density, and the irradiance to deliver a nice full cure is incredibly important. So with that, I think I have about 10, 11 minutes left. I'm going to open that up to questions and ask Sarah and myself will be on to answer some of these coming through. So Chelsea, if you could just start asking some of those questions.
Yeah, great. So we've got quite a few. So I'll just dive right in. Does volume, high BCM, affect curing? If so, what is the difference with conventional UV curing?
So volume certainly does affect curing. And when I say volume, I'm thinking maybe the question was around speed of the press. And so that goes to the question around energy density and irradiance. It certainly does. We're seeing, as I stated earlier, when we think about output, that's all about how fast that press can run. We're seeing on the mercury systems, again, you have to look at the formula, the whole combination, but we're seeing those customers who move to UV LED dial in all the chemistry that's needed, the consumables that come along with it. If they dial it in, they're usually seeing their presses increase anywhere between 20 to 40% in total output. Now, that's volume. That's the amount of speed that they can run their presses at. Sarah, anything you want to add to that?
So regarding BCM, that has to do with the amount of ink that you're laying down. We have seen that LED is able to penetrate that ink better than a mercury system because it has that deep, the UVA, UVB region. And so it's able to penetrate that ink, and it actually cures from the bottom up. So you're going to get great adhesion, you're going to get great through cure, and as long as the ink is formulated correctly, you get proper surface cure as well. So we don't really see an issue with thicker laydowns, and actually a rotary screen application where you're putting down even more. LED is fantastic for those really opaque colors, the really dense whites and opaque blacks. So for volume, LED is, I think, a good solution.
Well, building on that, this question says for opaque whites or high volume UV, do they want more irradiance or do they want more dose?
So currently, we've seen good cures. This is the metric where we can see 1,000 feet per minute with 20 watts per square centimeter. That's with the narrow window. So it's probably more about peak irradiance for the whites, but really it's a wavelength thing. Whites absorb the UVA really well, and so you actually get better cure than you would with a mercury lamp that's trying to cure throughout the entire UV spectrum. So whites are fantastic with LED in that 395 range.
Okay. And then someone is asking if we can explain again quickly the relationship of the ink coating coat weight to irradiance and dose. That's a question.
So this one we'll probably have to I would say work with your ink supplier. We do work with all the major ones, so they have our light sources on site. Typically, they can give you demonstrations, or there's places we can show you demonstrations. It could vary depending on your ink supplier, but as long as they can show you firsthand, I think that's probably the best experience, just to see it actually working on site.
Okay, great. So this question says they thought that UVA was what they wanted to have to cure safely, and that UVC was not desired. So they're asking, what has changed in this information since UVC systems are starting to come out?
So I think I'll answer that, from my view, and then ask Sarah to jump in as well. So from a UVA perspective, yes, it's a safer experience. Certainly need to take the precautions for any UV energy that's coming out or light that's being emitted. It is safer than UVA. UVA, you have to take much bigger precautions. You have to make sure that the light is channeled in a way away from the operators and will not be impacting those operators. But there are ways that we can shield and make sure that light is being directed in the right way. So, Sarah, anything else you want to add?
So just to correct you a little bit there, the UVC is the dangerous one. That one, basically you can't see that output, and so it'll burn your eyes before you can see it. So there is still some danger there optically, and it does create ozone down at the UVC range. So UVA is great. That's what we've worked with for the last, since Phoseon was founded, and the formulators have made successful inks that work at that range. Basically, the UVC is giving us a little bit broader availability of the photo initiator packages. And so we see the UVC coming in down the road to help maybe reduce ink costs at some point. But that's, I think, in the future a little bit as the UVC develops. And then we will have to take into account those other concerns with UVC as far as shielding it properly to make sure that you don't have any visible light or the UVC light coming out, as well as the ozone extraction. So we're not there yet. UVA is still a great solution today, but we're keeping our options open for the future for future technology developments.
So I'm going to stop asking these technical questions because obviously the coffee hasn't kicked in for me as I keep flipping around various terminologies. But thank you, Sarah. And Sarah, keep answering.
Okay. Yeah, and it's very early in Portland for them this morning. So, and we've got some great questions here. So this question says, I believe that infrared can actually assist in the curing process of UV inks. Can the elimination of infrared have any detrimental effects on the curing process?
So we have seen that if you keep the inks too cold, that does slow down that curing process. So if you're running on a chill roller, we caution not to keep that chill roller too cold. Keep it at like 30 or 35 degrees C, basically around ambient or just a little bit higher. And then that gives us the capability to hit those 1,000 feet per minute speeds. The UV light that is output by an LED does not include IR, but it is a lot of intense energy. So as that gets absorbed and the curing reaction is kicked off, it does create a little bit of heat in that process. And if you were to stop the web in front of the UV LED light source, it will absorb that UV and turn into heat. So we do have to be a little bit cautious there. Just because it's the transformation of energy, it is turning into heat. So we have seen that IR can help the solution, but it's not necessary to reach our target curing speeds.
Okay. And then we're kind of at our time, but if everyone's happy, I'll maybe ask a question. We've had a lot of questions on ROI. And so what's kind of the expected ROI if they upgrade their existing FlexoPress to LED? Like what kind of factors play into that?
Do you want to take that one, Keith?
Yeah, I'll take that one. So when we think about ROI, or total cost of ownership, many factors come in. I'll just go through some of the experiences that we've had. We have seen that if you're moving from a water soluble types capability, that the amount of selections of various inks can be consolidated into one, which helps with the operation side of things. The key ROI, as I mentioned before, is all about the uptime and the ability to have a more productive press and putting out more product, more labels. And if you can do that, that really changes the ROI, or the total cost of ownership. And so we're seeing anywhere from 6 months to 2 years is the typical the payback period. And then after that, as the press is running and the lamps and the UV curing solution continues to run quite healthy, it's going to run for the next 3 to 7 years, depending on how well it's maintained in the environment that it's in.
All right, and then quite a few questions too about hybrid solutions, and when would those be appropriate?
So, from our view, let's be very clear. We are 100% UV LED curing provider and don't offer hybrid. And so take that as from our perspective. But everything that we've found with those who do choose a hybrid solution, once they have used UV LED and they have dialed in their formula for success on UV LED, they don't go back. And so hybrid's about moving back and forth. And I can understand that in an automobile environment, but on a curing solution, once you dial it in, you don't go back. And so hybrid solutions have a lot of overhead. Why do you need to carry the mercury overhead still when you move to a UV LED 100%? And we don't see customers going back once they've, again, dialed in that formula. And so why keep all of that infrastructure that's needed for a hybrid environment when you're going to, once you've dialed it in, and you should be able to do that very quickly, move forward with UV LED. Sarah, anything you want to add?
Basically, it's about as you said, it's the infrastructure, it's your air exhaust system, it's the maintenance that goes around the arc lamp, and so you're not really getting all of the benefits of the LED system if you're also having to deal with the drawbacks of the UV system. So we've seen the ink manufacturers and coating manufacturers all have LED solutions today, and so we don't see a reason to need to go backwards, like you said, to the traditional UV system.
And this question's about the 275 nm UV lamp in development. Does that produce ozone?
This would be a UVC lamp. I believe there is some ozone created because it is UVC. And so that technology is still too new, I think, to be a viable commercial solution today. But as we move forward with that technology and continue to develop it, we will have solutions to deal with that ozone that's created.
Okay. All right. Well, we've gone a bit over. I thank everyone for being here today. And thank you to Sarah and thank you to Keith for answering questions and providing a really, really great presentation today.
Well, thank you. Thank you for those who came in and listened. We appreciate it.
All right, thank you. And again, this will be available at labelsandlabeling.com if you wanted to take another look at Keith's presentation. So thank you everyone for being here. Have a great day.